In part 1 we set up the spectrometer configurations, setting which elements we were going to do on which spectrometers and using which crystals. But what we did do is we just accepted the default peak and background positions. In this second part we're going to look at how to peak the spectrometers to find the peak position, and we're going to look at a way of determining where's the good place to put the background positions. As an aside, we're also going to look on how we set interference corrections. So if you look at the elements and cations, here we see that we have the on-peak position and the off-peak positions. So we're going to set those. First thing we're going to do is we're going to open Automate. Probe software has a really good way of peaking spectrometers because the software knows which standards we're using and it knows which elements we want to analyse. So if you look at the standards list, you can see we've got some positions stored there. Now this lists all of the standards that we have positions for, not just the ones we've selected for this project. However, if you click Select Standards, it only selects the ones that we've got loaded. What we can do first, before we peak the spectrometers, is we can check that the positions we've got stored for those standards is still valid and correct. So what we can do is we can click on Confirm Standard Positions. I'll just select one of these to start with. So we've selected Confirm Standard Positions, we've run the selected sample, so it says we've got one sample selected. Now what the instrument will do is it'll drive to the spectrometer position that we've got stored, and we've got a set number of seconds in which to answer, or we can click Pause. And we can now check the focus on our standard. We can move to a slightly different position, and if you move to a slightly different position and set OK, it'll update the position for that standard, and you can do that for all of the standards. I won't show it for all of the others. So again, we go Select Standards. We don't want to confirm the positions. What we want to do now is we want to peak the spectrometers, and you'll see in the automation options we've got the option to peak on assigned standards, and this is what we want to do. So we make sure that is selected. If we click on the little peaking button, we can see we've got all the elements selected. We've got ROM-based centering, and what we can do is we've got several options down here. So we can run pulse height analysis either prior or after peaking, and we can do PHA scans after and before. But we're just going to do peak for this example. I'll deselect that one. We also have the option to display a pre-scan for confirmation. Now if you think your peak might be quite a long way shifted from its ideal position, for example if you've just changed crystal or you've done any maintenance on the spectrometer, that can be quite useful to do. So I'll select that so you can see what it looks like. Now what we can do is we can check the count times that it's going to use for doing the peaking. It's going to do 1 second. So that's okay, but if you select any of these, you can change the peaking count time. The other thing we need to do is, or that's wise to do, is to select the peak scan options and to check the use continuous spectrometer scanning. By default, when you're doing a spectrometer scan, the spectrometer will move to the incremented position, it'll stop, it'll then count, and after the count it'll then move to the next position. This is quite slow because there's a lot of stopping and starting and moving. What the continuous spectrometer scanning does is it drives the spectrometer at a speed which means that over the interval you've counted for the allocated time. There's a limit to how slow or how fast you can do, which is dependent on your instrument, but most instruments are actually quite versatile in how wide a range of settings they can use. Now we've got peak spectrometers, we've got our three metals, our three standards selected. We now click Run Selected Positions. It'll ask if we want to do the pre-scan option, and we'll select Yes. Again, it'll tell us how many samples we're doing, so this is a quick check to make sure we have selected what we think we've selected. And the instrument will now drive to the first standard, which is the copper metal, and it'll start running the peak scan. So here, since we're on the copper metal, it's running the copper K alpha peak scan. It's just setting the operating conditions that we've selected. Now, because we've selected to do a pre-scan, this is quite a wide scan, and once it's finished doing the wide scan, it'll ask us to select or adjust the peak position so as you can see the optimum position is slightly off peak, so we can either click and drag or just click the end box until we've got it near the center. It doesn't have to be precise. We click OK and it'll then actually start doing the proper peak scan. Once it's found the centroid position, it'll write that value back to our element setup, so it'll automatically update the peak position. I'll move that over. You can now see it's moved to the nickel sulfide. Now, because we're doing both nickel and sulfur on this standard, it'll do both peaks simultaneously. And again, we can adjust the position of the peak for the nickel, and the sulfur looks good, so we just say OK, and that'll now start doing the peak scanning. And finally it'll move to the iron standard. Adjust the position for the pre-scan. If you haven't selected to do the pre-scan, there's no user intervention required. It'll just do the peaking in turn and then finish without you having to sit and click OK to each thing. And that's the peaking finished. And it tells us the automation is completed. So we can now close that. Now the nice thing with probe software is because it saves everything, we can always go back and re-inspect our peak runs, and if you've done PHA spectra as well. So if you go to the run and display fit and export spectrometer peaking and PHA scans, we'll see that we've got both the pre-scans, which are the wider scans, and also the ROM scan, which is the actual peak scan for each element. If you've done any PHA scans, these will also appear here. One difference between the peaks and the PHA scans is that whilst the peak value is automatically written back to our elements and cations, if you do PHA scans, you need to manually enter those values back into the element settings. So if we check the iron, 134.62, 134.624, so it's correctly written those values back. Now, if this is a material type that you're not very familiar with, so you're not very certain what the background positions would be or what interferences there might be, it's a good idea to run a wave scan. Now, you can either do that by doing a new sample setup, selecting a wave scan and running it on each of the standards or on your sample. But Probe software actually has a very nice and quick way of doing it on all of the standards that you've got selected. So having the standards selected, again, if you don't have the one selected, you click select standards and it'll select the ones that you've got loaded for your set type. We click digitize positions and then click positions, and again select the standards, and now you've got an option here as duplicate as wave scan. So it'll take these three standard positions and it'll now generate a wave scan setup for each of those. So if we now close that and that, we've now got the three wave scans automatically set up. Now we can check the count times. I think wave scan 5 seconds is a bit much, so let's take that down to 1 second, and that'll change that for all of those. Again, we check the peak scan options that the ROM spectrometer scanning is saved. Now, by default, the spectrometer scan is set so that it'll have the peak in the center of the scan, and it'll be wide enough that it'll include both background positions and an area of spectrum either side of it. You can, if you wish, change the higher and lower limits, the number of points, and other settings as you wish, but I'll leave them as the defaults. And if we just select those three, we'll deselect peak spectrometers, click on acquire wave scan samples and run selected samples. It tells us it's 3 samples and it'll take 17 minutes. So I'll start this running, but it's that easy. We'll just watch the first one starting up. So these are the first 3 elements. So we look at our diagnostic up here. It shows us what the spectrometer is doing. The yellow bar gives us a progress of how far we've got. So we're doing sulfur, nickel and copper first. So sulfur, nickel and copper. I'll let these run and I'll cut back when these wave scans have completed on all 3 samples. Okay, so the wave scans are now completed and we get an automation complete confirmation. So we can close that window. To investigate the acquired wave scans, we use the plot button. And here we see our 3 standards, and we have a choice as to what we have on the x-axis and the y-axis. Now what's quite useful is we can block select all 3 standards. We'll look at the iron first on spectrometer 3, and we want the spectrometer position relative to the wave scan counts. Click output. And here we have a plot of all the spectra overlaid. In red we see the peak position, and then in green we have the current set background positions. Now at the moment the background is looking very low because we've got a reasonable sized peak. But what we can do is we right click on the background of the graph and we select customization dialog, and then the axis tab. We can change the y-axis to logarithmic, and that allows us to see the background. Now the background positions for the iron look okay, there's no obvious interferences, so I think we're okay with that one. Now rather than click here and here to move down to the next element, you can just click the down arrow and it'll automatically move both axes down. So we can now look at the nickel on all three, and we can see here that there's a peak starting to appear at the right hand side, but it's clearer where the background positions are. Again, let's change it to logarithmic, just to make sure, and that looks quite good. Now if we want to check what peak position that is, we can put KLM markers. At the moment we've got none selected, but usefully we can just say we want the analysed elements. So we can see this is the tail of the iron K beta coming in here. And if we go down to copper, now here we've got an obvious problem with one of the background positions. So what we need to do is we need to move this background position. So to do that, we click, because this is the low background position, we click low, and then we can just click and select where we want the background to move to. And that'll write that value back to the element configuration. And as it says, the new parameters will take effect on the next new sample that's set. And finally look at sulfur. And again there's a potential problem with the background. We check analysed elements, and that looks like an iron K beta 3. Again, let's just check with the log scale. And I'd say we need to move that low background as well. Let's move it out there. Now one thing that's useful, the background on all of these elements is fairly linear. But if, for example, we selected the nickel sulfide and we wanted to look at the sulfur, and again we produce the peak, and again we'll look at the logarithmic axis so that we can see it more clearly. What we can also do is we can model the background. So we've got options here. The default is for a linear background, which looks reasonable in this case. But what we can do is we can take the average, which if you've got symmetric peaks is going to be roughly the same as drawing a line between the two ends. You can use the high only, so this is only taking this with a zero slope, or the low only with a zero slope, or you can take the high position and actually set a slope value. So if we change that, you can see that we're changing the slope value. Or again with the low. The penultimate option is that you can do an exponential fit. This is useful if you're doing elements close to the low end of the spectrometer range where the background is sloping. In this case there's not much evidence of any slope. You can also do a polynomial fit where you can change the polynomial conditions. Multi-point backgrounds we'll go into in another video, but we'll just change that as linear. Now if you did want to change that background, we would want to change it for the nickel sulfide definitely, but we may want to change it for all the others as well. You select which ones you want to assign it to, and then assign that background model to the selected samples, and it'll update all of those samples with the new background modelling profile. Now we didn't have any obvious interference problems with this, but the intermetallics quite often have problems with the beta peak of one element interfering with the alpha peak of the next element. So I'll show you how we can go through setting up an interference correction. Now interference corrections are corrected for using our assigned standards, so we go to the standard assignments to set this. So say for example we wanted to say that nickel interfered on copper. So we select the copper, and you can see here that there's a table where we can set up interferences. So if we say the interfering element is nickel, it's a first order interference, and the interfering standard we want to use is the one with the nickel in it, is the nickel sulfide. Now what you can also do is you can calculate what the WDS interferences are for the elements that you have selected, up to a maximum of 5th order, but you can go up to much higher than that. If you're brave, you can check all interfering elements, and that'll check the entire periodic table, which always gives you quite a long list. But if we now select OK, we can now see that copper has nickel as an interfering element, and we're using the nickel standard to correct for that. And that's part 2 completed. In part 3, we'll look at how to calibrate our standards ready for doing quantitative analysis.